This lesson is about Pythagorean theorem, proving right triangles. Let's look at our first example. The question asks, is a triangle with side lengths of 3, 4, and 5 a right triangle? The diagram that's here shows us side lengths with 3, 4, and 5. Let's see how we do that using a formula. First thing I'll always get you to do is label your triangle. So we know our right angle is here, so that means directly across is C, and our side lengths will be A and B. And what we want to prove is that A squared plus B squared is equal to C squared. And we can actually count them here because we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And here we have 16. And we have 16 over here. This image illustrates nicely why we do have to take the square root at the end, because what the square number is actually finding that area of the entire square. So in order to get the side length, we need to take that square root. Let's have a look at what that'll look like if we're using formulas. When showing our work algebraically or using a formula, the first thing I like to do is label the triangle, but we've already done that. The next step will be to write down the formula. A squared plus B squared. And I like to write my C squared on this side. It means the same thing. The next thing we're going to do is we're going to sub in the values that we know. So we know A is 3 squared, and we know that B is 4 squared. Next, we'll actually do that math. 3 squared is 9, plus 4 squared is 16. Add those together, which gives us 25. Bring our C squared down. And the reason I do that is because now that we have what that square should equal, to get C by itself, we have to undo that square by using the inverse operation of square root, which will give us C equal to 5. And because we can see over here that C does have a side length of 5, then yes, it is a right angle triangle. Let's look at another example to see how this works. Here we have another triangle with side lengths of 8, 15, and 16. So I'm going to start by labeling the triangle. I'm going to assume that the right angle is probably here, if it is a right angle triangle, making this side C and A and B. And the reason I do that is because when we're labeling, we want the longest side, the 16, to be where we think C might be. Okay, and then it doesn't matter where your 8 and 15 go. Once you have it labeled, let's do a check using Pythagorean theorem. So A squared plus B squared. And again, I like my C squared on the left-hand side. Okay, we have 8 squared plus 15 squared, which gives us 64 and 225. Add it together, it gives us 289. We bring down that C squared, square root, which gives us a side length of 17. All right, so let's go back and see what information they gave us. They said side length of 16, and we know, using Pythagorean theorem, if it's a right angle triangle, C would need to be 17, and because those two aren't equal, this is not a right angle triangle.